Now welcome to this latest video on 162 Maths, and in this video we'll be going over a GCSE Maths higher topic test on reoccurring decimals to fractions. Now, as well as going through some exam questions, I'll include a lesson that goes over this particular topic as a link in the description below. So if you're not sure about how to convert reoccurring decimals into fractions, I strongly recommend that you watch that video before practicing some exam questions. I'll also include a link in the video above as well. Now, a copy of the questions that we go through in this video are also available for you to download by click on the link in the description. Now, if you're wanting step-by-step guidance on how to convert recurring decimals into fractions, then I strongly recommend that you check out the lesson which goes over this particular topic in more detail and talks you through how it is you actually do this. Now, if you're wanting a copy of the test questions that we're about to go through in this video, what you need to do is to simply click on the link in the description. So looking at question 1, so this time here we're doing usually the opposite, which is having a fraction and we want to show that it's a reoccurring decimal. So in this particular question it's asking us to convert 1/6 into a reoccurring decimal. Now how we do this, the best way is probably using division, and typically the bus stop method. So the denominator always goes outside the bus stop and the numerator goes inside, and I always recommend that you have a few zeros, maybe at least 4. So then it's just a case of seeing how many 6 are going to 1, that's 0, remembering the decimal point, and then we carry any numbers that we don't use, so we've carried the 1. How many 6 is going to 10, that's going to be 1, remainder 4. How many 6 is going to 40, that's going to be 6, remainder 4. Then 6 again, remainder 4, and slowly you can spot that I'm going to constantly have that remainder of 4 and keep getting 6. So the reoccurring decimal is what's on the top. Now you don't need to do a written explanation, but just writing your answer as 0.16 with a dot on top of the 6 should be absolutely fine. Moving on to question 2, it says convert 1/11 to a recurring decimal. So again we do exactly the same. So 11 goes outside the bus stop and 1 goes inside, and again just have a few zeros for good measure. So then 11's into 1 goes 0 with a decimal point, carry the 1. 11's into 10 goes 0, so then we carry the 10. So then how many 11's going to 100? Well, that's going to be 9, remainder 1, and then it's going to be a 0, then it's going to remain to 10. So what's going to happen is that we're going to get our reoccurring decimal of 0.09 with a reoccurring dot on the 0 and a reoccurring dot on the 9. Question 3, it says convert 0.1 recurring into a fraction. So again with this you want to make it equal to x. Then you want to multiply by 10 until we get that repeated pattern after the decimal point. Then taking these two, now what you want to try and do is make sure that you are writing the big one, take away the smaller one. And I'll just explain what we then do. So we get 9x equals 1, so x equals 1 over 9. Now if I went on to looking at purple, and let's say I took this away and I said, oh, that's 9x and that's going to be 1. Technically that is incorrect, because actually it's -9 and -1. Now failure to do this may cost me a mark, so the marker may knock a mark off, because technically your working out is invalid. There is an error in your working out, which means then they can penalise you in terms of those method marks. So when you have got that repeated pattern after the decimal point, I would strongly recommend that you rewrite it again, but have the bigger one at the top and the smaller one at the bottom, so that you're not having to deal with any negatives. Moving on to question 4, so it's express 0.113 recurring as a fraction. So again we make it equal to x. Now here what we want to do is want to have a repeated pattern after the decimal point. Now you can see you've got 3 numbers after the decimal point that's being repeated. So then I multiply that by 1000, because that's got 3 zeros, and that will give me 113.113 recurring. So then taking these, so we get 1000x equals 113.113 ... We've got x, which is 0.113 ... Now remember that the x's do not cancel, it's 1x, so we take away, so that becomes 999x equals 113, which gives me an answer of 113 over 999. That doesn't simplify, so that there is my final answer. Moving on to question 5, it says 0.45 recurring. So again, make it equal to x. Now here I've got two numbers repeated in the pattern. So I'm going to multiply by 100. So I get 45.55. And then again, as you can see, I want two expressions of x where I've got the same repeated pattern after the decimal point. So then from this, I've got 100x equals 45.45 recurring. I've got single x, which is 0.45. And again, presentation is really key to stop you from making any silly errors. So here I've got 99x equals 45. So x equals 45 over 99. But you've got to note that the question says give your answer in its simplest form. So I need to simplify that. I notice that both those can be divided by 9. So it's going to be 5 over 11. Moving on to question 6, and as you can see, these questions are very, very similar, but here, what you notice here, that only the 3 is being repeated. So again, if I multiply it by 10, I get 2.3 recurring, but again, I can't use those two because I haven't got the same pattern after the decimal point. So then I multiply by another 10, in which I get 23.3 recurring. So now I can use these two things here. So if I write it out again, and 10x, which is 2.3 recurring, that then becomes 90x equals 23 take away 2, which is 21. So x equals 21 over 90. Remember, you need to give your answer in its simplest form, so we can divide both numbers by 3, so it's 7 over 30. Moving on to question 7, it says convert 0.035 recurring as a fraction in its simplest form. So again, make it equal to x. So again, if I multiply by 10, I get 0.35 recurring. Multiplied by 100, I get 3.53 recurring. Multiplied by 1,000, and I get 35.35 recurring. So I'm going to be using this and this. So I get 1000x equals 35.35 recurring, and 10x, which is 0.35 recurring. Take two things away, I get 990x equals 35. So x equals 35 over 990, which I can divide both numbers by 5, so that's 7 over, and I believe it to be 198, so it's 7 over 198. Now if you're questioning where did I get 198 so quickly, well, I know that I'm dividing by 5, so again, it may be a case of where I just need to do 5 over 990, in which I'd end up with 198. Moving on to question 8, again, we make it equal to x. So I've got 5.63 recurring, multiplied by 10, and I get 56.36 recurring, multiplied by 100, and I get 563.63 recurring. I've then got a repeated pattern here, repeated pattern there. So I've got 100x equals 563.63 recurring, and x equals 5.63 recurring. So then taking them away, gives me 99x equals 558. So x equals 558 divided by 99, which again I need to give in its mixed number in its simplest form. So that's going to be 5 and 63 over 99. I then need to simplify this fraction here. So that then becomes 5, and dividing both numbers by 9, I get 7/11. Moving on to question 9, it says work out 0.54 recurring minus 0.37 recurring. Give your answer as a fraction in its simplest form. So first things first, let's convert 0.54 into a fraction. So first we'll make it equal to x, and then we multiply by 10, so that gives us 5.4 recurring. That doesn't work. Do 100x, and that gives me 54.4 recurring. So then I can then use these two things here. So 100x equals 54.4, 10x equals 5.4 recurring. Take the two things away and end up with 90x equals 49. So x equals 49 over 90. And I'm just going to highlight that for the time being. Now the next thing for me then to move on to is 0.37 recurring. So again, going through the same notions, multiply it by 10 and I get 3.7 recurring, multiply by 100 and I get 37.7 recurring. So then using those two, I get 100x equals 37.7, 10x, which equals 3.7 recurring. Take the two things away, 90x equals 34, so x equals 34 over 90. Now you might be thinking to yourself, do I simplify? Well, the fact that I'm going to have to take away these two things, it's easy if I don't simplify. So here I've got 49 over 90, which is 0.54 recurring, minus 0.37 recurring, which is now 34 over 90. 49 take away 34 is 15, so it's 15 over 90, which dividing both numbers by 15 gives me 1 over 6. So the answer then is 1/6. Then moving on to question 10, it says 0.1 equals 1/9. Use this fact that 0.01 recurring equals 1 over 90. So for this, what we've then got is, well, we've got that 0.1 divided by 10 equals 0.01 recurring. Now, if I wanted to convert this into fractions, well, that's 1/9 because it tells me in the question, divided by 10. Now, if I convert that into a fraction, then that becomes 10 over 1, which then becomes, flip the fraction, so it becomes times 1/10, and that then becomes 1 over 90, which is what they wanted me to show. Then for part 10b, it says using part A or otherwise convert 0.51 into a fraction. Well, again, I can just do more traditional methods, but using the answer in part A, I've got 0.5 plus 0.01 recurring equals 0.51 recurring. Now this is just a half, and this I've worked out is 1 over 90. So then adding those up and getting common denominator, that's going to be 45 over 90 plus 1 over 90, which is 46 over 90, which I can simplify to give me 23 over 45. Alternately, what you could have done is you could have done, if I've got space, x equals 0.51 recurring, 10x equals 5.1 recurring, 100x equals 51.1 recurring. Using these two things, I get 100x equals 51.1, 10x equals 5.1. Take the two things away, I get 90x equals 46, then 46 over 90, which is 23 over 45, which is the same answer. Then moving on to question 11, it says prove algebraically 2.32 recurring equals 209 over 90. Now, don't let this confuse you. This is exactly what we've been doing. We've been using algebra to convert these recurring decimals into fractions. So first of all, make the decimal point equal to the decimal answer. We then multiply by 10, so we get 23.2 recurring, multiplied by another 10, so we get 232.2 recurring. Then using these two things here, we get 100x equals 232.2 and 10x, which equals 23.2. Take the two things away and I get 90x equals 209, so x equals 209 over 90, which is what they wanted me to show.